morning. So, do you remember we started solving some problems? I think I gave one problem to you. We didn't have time to go through it. We checked it using Wolfram Alpha, but let us to go through it and then refresh your memory and then continue the lesson. So the equation was this equation. So y prime minus 4y equals to sine 2x minus 3 cosine x. Yes. In one problem, we solved something similar, but they have the same angles in front of sine and cosine. These have different two angles. But I told you that because this equation is a linear differential equation, if you want to find a particular solution for this with this combination on the right hand side, you can find a particular solution only for this part, and then you can find a particular solution only with this, and then add them up. I don't want to go through the reasoning again. Hopefully you remember this method is valid. Yes.
Just example change. All of the equations which were of this form y prime minus ay equals f of x,
Yes.
all of those are linear, right?
Yes.
Yeah. Okay.
All of them are linear. So even if this is px, that's also linear because the differential, if you have time as an optional thing, we can go through this a little bit today because officially the lesson is finished. So if you have a differential equation of this form, even if this is not a constant, it's a function of x only, that's a function of x, that's still a linear differential equation. Okay, so let us try to understand the problem. I know that you know what to do. The first thing you have to do is to find the homogeneous one. So the solution to the homogeneous one, which you can read it from the formula sheet, it is c e to the power of negative this number, which becomes 4 and then times x. So this is yh. But for the second part, because one of them is 2x, one of them is x, I have to consider two scenarios because of linearity. Otherwise, this method is not valid. So this, I consider this problem and find the particular solution for this. And then I consider this problem and I find a particular solution for this. According to what I told you last time, if I find a particular solution for this and add it to the particular solution to this, then I will have a particular solution for my differential equation. Okay, for finding a particular solution for this using the method of undetermined coefficients, we should have an educated guess and then do some analytic work to find the undetermined coefficients. For this case, if I call it yp sub 1, what is the good guess? It is a constant a multiplied by what? Sine 2x plus b cosine 2x. Hopefully you remember. It's a good guess for a particular solution for this. For a particular solution for this, I don't know. I can see, because this is cosine, I need to still consider both sine and cosine, but with argument x. So I call one of them c and one of them d. So I have to be patient, solve one problem here, another problem there, and add them up, and then add it to this one. Okay? So what should I do now? I take the derivative of this one for the first one, so it becomes y p1 prime is 2a cosine 2x. Because of the chain rule, there will be a 2 out, and then minus 2b sine 2x. I take this and put it here in the first equation. Y is this, and fine-tune these a and b. Okay, so what I do is this. I put them in that equation. So y prime is that expression, so it becomes 2a cosine 2x minus 2b sine 2x. Yes, this one is for y prime. But then I have minus 4 times a y. So I have to multiply y by minus 4. So minus 4 goes here and there. So it becomes minus 4a sine 2x and then minus 4b cosine 2x. This is supposed to be equal to the right hand side there, which is sine 2x. In order to be able to compare, we collected similar terms. So for example, here I have a cosine 2x here and a cosine 2x there. So if you want, I can factor a 2 from the left and a cosine 2x from the right between these two terms, this one and the last one. So what happens? This becomes a minus 2b, yes? And similarly, I can factor a minus 2 from the left between these two terms and a sine 2x from the right. And then here I will have b plus 2a. This is the organized way of writing the left side, and then sine 2x is on the right side. And then I start comparing them. And I told you the logic is not to find all possibilities because one is enough for me. One possibility is to take this coefficient to be 0 because I don't see any cosine 2x on the right, and this coefficient to be what? 1. And then you solve the system. So that was a guesswork, but this is not easy to guess A and B. We are doing it systematically. So from the first equation, I get A is 2 times larger than B, and I put it here. So this means that I divide by minus 2. Instead of B, I write B. Instead of A, I put 2B times 2 is 4B. It's minus a half. So B becomes minus 1 over 10. And then A becomes 1 over minus 1 over 5. Yes? Yeah, do you agree? Okay, and then I have yp1 in its full form. A minus 1 over 5 sine 2x. And then what is B? B is minus 1 over 10 cosine 2x. That is yp1. Then I have to do something similar for the second one. I take this one and then differentiate that. The derivative is also very similar to the first one, so it becomes c cosine x minus d sine x. And I take this one, oh, this is derivative, sorry. I take this one, put it here, and this one, put it here, and then do the same thing. So what happens? Y prime, it becomes c cosine x plus, not minus, d sine x. This is for y prime here. Minus 4 times y, so I multiply minus 4 here and there. So it becomes minus 4c sine x minus 4d cosine x. It's supposed to be equal to minus 3 cosine x. And then what I do between this one and that one, I can factor cosine x out. Between these two, between these two I factor a minus sign from the left and a sign from the right. And then I have this on the right and the same story. So this c minus 4d should be minus 3 minus d plus 4c should be 0 because there is no sign there. So from here, d becomes minus 4c. I put it there. The numbers are weird. Are these numbers the same numbers that we checked last time? Do you have your solutions? So I don't remember. I think the numbers were not these. Anyway, but because if I put it here, it becomes 17. So this means that c is minus 3 over 17.
That's what we got.
Ah, okay, so that's correct. And then d becomes 12 over 17. What about the previous numbers? The previous numbers are also correct?
Yes.
Because, okay, that's good. Okay, so then it means that yp2 is what? yp2 is c minus 3 over 17 sine x plus 12 over 17 cosine x. This is yp2. But if I ask you what is yp, yp is the particular solution for my original equation. I hope you remember I convinced you that this particular solution is the sum of these two. And then the solution that I am looking for is yh plus yp. But yp itself is two parts, so it becomes yh plus yp1 plus yp2. Yh is ce to power, it is 4x. And then the rest of the story. So I will add that one, minus 1 over 5 sine 2x. And then I have minus 1 over 10 cosine 2x. And then I have this expression, so minus 3 over 17 sine x plus 12 over 17 cosine x. So y equals to this expression is the general solution for my differential equation. Yes? Okay. So at this level is enough, you know, for this course. But we go a little bit further. This is optional, so let me write optional. Okay, so what happens, do you think, if I want to solve this differential equation? So y prime plus 2y is equal to 2x squared e to dx. I just want to inform you about that. You know, it is different from this problem. This problem is at the right level for your course. If I give you this, hopefully you know how to solve it, yes? Why? Because you know how to solve this one, you know how to solve this one, and this is the sum. Or difference, it doesn't matter. For sum and difference, this method works. Yes? But if I multiply, even linearity doesn't guarantee that I can do this separately and multiply. Okay? So I just want you to think about it a little bit. If I want to solve this problem, is there something I can do? Of course, except the integrating factor method, because that method will, of course, will solve the problem. I told you from the beginning that method solves all those sorts of problems. But the problem is that finding the primitive function of a product is usually not that easy. So still, I want you to use the method of undetermined coefficients. Of course, the first part of the algorithm is unaffected. So what you do, I just know the answer to this part. Okay, so the problem is again finding a particular solution. Okay, yes.
So my first thought is that we put y is equal to ax squared ex, and then we take the derivative of that. So we have to use the multiplication rule to get the derivative.
Okay, let us test this. So your idea is to do the method of undetermined coefficients. You have a guess about your particular form. So your guess is to do what? So yp, to write it what, as you said?
Yp is equal to ax squared ex.
2a.
No, just a.
Just again?
Ax squared ex.
Okay. Something like that. Okay, let us see if it works or not. So you are saying that, check this one, okay? So if I want to take the derivative of that one, what should I do? Because that becomes a product rule, then I have to use the product rule. So it becomes the derivative of the first one, 2x, so 2ax multiplied by the second one, but plus what? This one multiplied by the derivative of the second one, but the derivative of e to the x is e to the x itself, so it becomes ax squared e to the x. Okay? And then what we are doing, I have to put it back here in order with the hope in mind that I will be able to fine-tune that a. If that's okay, because the logic is to just find one, it doesn't matter how you find it, it will work. But let us see. If I put that there, what happens? Yes. This one is for y prime. 2 times that. And then I have 2x squared e to the x. And then if I simplify things, these two becomes 3a x squared e to the x, 2a and a. But this is alone, so I have to write it like this. Okay, do you think now I can fine-tune it? No. Yes? But it was not that bad, guess. The problem is that this is a problem here for me, yes? If it was not there, then of course you are right. Okay, it was not very bad. That's the reason I actually started doing it. Okay, what is the other guess now?
Maybe you can try the idea of adding the other part so you create a squaring pattern for the, no, it's not
Yeah, I'm not expecting you, even I couldn't guess probably, because you know that for addition it is easy by linearity, but linearity doesn't give any tool in my hand so that I can guess for this one. So that's a theorem, more or less. Someone has thought about this and found an idea. The idea is, so if the idea is very similar to this one, that's a little bit strange. So if you want to guess something for this, how do you guess? You guess one for this part, which should be of which type? A second degree polynomial. And you guess one for this one, which should be a exponential function. And then you say that because this is addition, linearity guarantees that the sum is also a particular solution. But it turns out that for the product, that's also idea, the product will work. Okay, because I'm not saying that the product, so I'm not saying that if you find something for this and something for this separately, the product is definitely the solution for this. But I say that if you guess as if it is a sum, you will see it will work. Okay, so let us try to do that. Okay, so tell me if you understood what I said, even though at this moment you don't believe in it, because there is no reason to believe in it. What do you guess for my product, for my particular solution? What do you guess?
It's the same idea, then you would take two cases, one being 2x squared and
So what should I write?
2
ax squared plus bx plus c multiplied by e to the x. Okay. Okay, so the point is that now if I take the derivative, what happens? The derivative of the first one, that is still a product rule, but the derivative of the first one becomes this, multiplied by the second one, and then plus the first one multiplied by the derivative of the second one. Do you agree? Yeah. And the reason is now that you can factor an ax out, which is not a big problem because you want to have ex on the right. And what is left for you is a second degree polynomial that you want to match with a second degree polynomial. Yes? So do you see that? Because now I have to add these two, but this can be written as ax squared. Between these two, I can factor an x out. And then I have to add the constants. You see what was the trick? The reason that it works is because of this. Because if you write like that, if you differentiate it, e to power x appears in both of them, and you take it out, and that e to the power of x doesn't pose any problems for you because that is also e to the x. And then you have a quadratic equation. So, and then you already know that this quadratic equation can be fine-tuned to be fixed with just a quadratic equation, quadratic function, yes? So can you tell me how should I adjust down everything? Oh, sorry, this is y prime. But I have to put it there as well. Yes, so I have still a little bit trouble. So this is my y prime. I have to put it there. So what happens? This is my y prime. This is y prime. Then I have the other one, which is y. This one, 2y. So it is 2ax squared e to the x. It is supposed to be 2x squared e to the x. Now I take an ex out. What happens here? So I have ax squared plus 2ax squared, so it becomes 3ax squared. And then I copy and paste the rest. And then this is supposed to be equal to this. So I am doing nothing, you know. I'm just claiming this is an educated guess, which is weird. Yes, because I am pretending that this problem is given alone and this problem is given alone. And even though it is not an addition or subtraction, it's a multiplication, I still insist that this is the case, yes?
I'm just running to where you just have the first term in the 2ax squared times e to the power x, and now it's the whole polynomial. So like the y.
Okay. Yes, you are right. Yes, you are right. No, because I was confused. I took that one. No, that one. Yes, and so it becomes. Thank you very much for fixing it. Okay, so what should I do? I have to write 2 times that one. Yes. So let me fix it. So this is y prime, and then I have what? I have y prime plus 2y. So y prime is this expression. Yes, this is y prime plus 2 times y. Yes. Now this is correct, yes? This is supposed to be equal to 2x squared e to the x. Yes, sorry. And now let us do this in our head, yes? I factor e to the x out. 2ax squared becomes 3ax squared. Yes? 2bx, and this will be added here. So it becomes 2a plus 3bx. And then I have 2c and c, 3c and b. Yes? And then I have e to the x. And then finally, this should work. Do you see any flaws now, or is it good? Hmm? It seems to be correct, yes? Okay, then compare. So it means that 3a, if possible, to make it 2, 2a plus 3b, if possible 0, b plus 3c 0. Yes, I'm comparing this part only with this part because they are in common. So from here, a is found. From here, I can find b. b is minus 2 times a divided by 3, so it is 4 over 9. And so c is minus 4 over 27. Let me double check. Yes. It seems to be correct.
Why is it minus? A was I minus.
I is positive, yes.
But then B should just be negative.
So yeah, no, this is not that easy. Yeah, it is negative. Yes. Say it is positive. So I was lucky at least for this part.
Yeah.
Yes, is that right now? Okay, finally, what is the final answer that you were supposed to provide? If everything is done properly, so I need to find that YH part, which is C e to power minus 2x. but plus the private one for these choices, of course. So it becomes plus 2/3 of x squared minus 4/9x plus 4/27, and then e to the power of e to power x. So we can check it using Wolfram alpha if we have done everything fine. But it was not expected, to be honest. I mean, there is no guarantee that if I have two particular solutions, so there is no formula. So let me just review this. If I have y prime plus ay equals to f of x plus g of x, linearity guarantees that if I have a solution for this and a solution for that, if I add them, it becomes a solution for the whole combination. But if I have this scenario, it has nothing to do with linearity. I cannot say that I solve this problem and that problem individually and multiply them, it becomes the problem, the solution for the problem, yes? But it tells you that this is a theorem, actually mathematicians has provided that for these three types of functions we had, polynomials, exponentials, and sine and cosine function, this idea works. Yes? Yeah.
But for cases where you don't multiply with e to power x, then it would be difficult to do this.
Yeah, it is difficult, lengthy. I'm not saying it is fun, but it is doable.
But our idea here was that we could factorize in e to the x outright.
No, in all of them you can, because otherwise the method of undetermined coefficient is not useful in the first place. I mean, if you have a sine cosine function, you can do the same idea. If you have polynomial function, exponential function, that's the reason that this is good. But it was a little bit of surprise that this is also working, because I wouldn't say this is a surprise because of linearity, but the product is also somehow working. There are some exceptions that you have to be a little bit more alert about that, but because it is not part of your lesson, I don't want to go through them. But let us check this using Wolfram alpha. I think we cannot hope that GeoGebra give us a good answer, but let me see how it works here. So I think we should write d-solve, meaning differential equation solve. And what is the equation? The equation is y prime minus 4y 4 times y. Yes, is that right? No, what was the equation? Plus 2y. Plus 2y 2y equals to what? 2x squared times exponential function. Let me just type it like that. Exponential of x. Yes.
Will it understand that it's not 2 to the power of?
No, it will understand. Yes. Yes. Hopefully. We shouldn't be worried about that part, because first of all it writes its own interpretation and then solve it. Yes. Yes, that is the differential equation in the correct form, 2x squared times exponential of x, and that is the answer that this will give us. Is that the answer we got? Yes? 2/3 x squared times e to the x. But of course in Wolfram alpha you see this is multiplied. But that is correct. Do you agree?
Yes.
Yeah. 4/27x is the last one, minus 4. Yes, everything is fine. So yeah, it was a little bit of surprise that this will also work here. Yes.
So if you had like.
So let us yes.
If you had like 2x to the power of 2 sine x, that would also work here.
Yes. And this becomes more complicated, of course. But there are, if you want, I can talk a little bit about the exceptions. Yes. Let me make it a little bit simpler calculationally, but my point is something else. My point is, if you let us go back to this equation, I want to make it less demanding from computational point of view. Let me take this one, because my point is to teach you something else. So if I write this minus, and let us take this factor of 2, and for simplicity, let me make it this, and then I ask you to solve this one. Let me see if everything is exactly as I want to. Yes. Okay. So what will happen here? if you want to solve this problem for, say, now you have a little bit of experience. Logically, you don't expect that this method works for multiplication, but for these special functions, this will work. But now you have a little bit of experience, but then there will be another trouble coming in. And also mathematicians learn how to solve that problem. But you don't face that problem right away. Let us say that we don't know about that, and we want to solve this differential equation as I described before. So the first step you do is just write the, write what? The homogeneous one and solve it. This is extremely simple, so it is CE to the x, yes? Because it is e to the power of minus ax, a is minus 1 here. But now can you tell me, if you learned what I told you, what is your first guess for yp? Ax plus b, yes? Because you see that's a polynomial of degree 1, and then you multiply it by that. Okay. I want to wait for you, you feel it for yourself, you will be in trouble. Okay, so just do that. Okay, did you see that you will face a problem? Yes, okay, so let us, everyone sees that. So if I want to do it as I guessed before, so my guess is not that bad. It's exactly according to what I told you. But I intentionally designed the numbers in a way that you face the same, it's to face a little bit of problem here. So why is that problematic here? Because if I take the derivative, it's still a product rule. It becomes the derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one. Yes? And then when I put it back into this equation in the original equation, what should I write? Instead of y prime, I write this. Yes? Minus y, which is this. Yes? And then it is supposed to be equal to the right-hand side. So now what happens is this one and that one are gone. Yes, and then I am in trouble. Because what is left for me is a e to the x. I want to force it to become equal to 2x e to the x. But this is not possible. Because a is a constant. The 2x, I cannot say that a has to be 2x. Be careful, because a is a constant. So a cannot be 2x. Okay? The source of this error, of course, I don't want to teach you in a very organized way, but I want to tell you what is the source of the error. The source of the error is, if you say this is the solution, in your head, if you multiply there ax e to the x plus b e to the x, the problem is that I intentionally designed the question in a way that e to the x, which appears here, is a solution to the homogeneous one. And of course, when I put that into this equation, b will not survive, because it doesn't matter what b is, e to the x, you see, this is the general solution of the homogeneous one by giving the role of constancy to b, of course. Then it is clear even from the beginning that b will vanish from my calculations. Do you see that? Because let me repeat, if I ask you what is this, you will tell me this is the solution for this equation for any c, any constant c, including constant b. Okay? So when I put that into the original equation, definitely that part will vanish, because that part becomes the solution of the 0 one. So b will vanish from the calculation. And that is why I am in trouble, because I need b not to vanish. Okay? Either we have to decide that the method of undetermined coefficients is not useful for this problem at all, or we should be able to fix it, and mathematicians have already fixed that. And the fix is very simple. Can you see about the fix?
Instead of writing ax plus b, we write ax squared plus bx plus c.
C is not needed again.
It will get cancelled out. Yeah.
Yeah, again with the same story, but that's correct. So if that's the reason, what you are saying is that mathematicians solve the problem like this. They say that, okay, multiply the whole combination by an extra x. This then will work. And that's what you said, because you told me ax squared plus bx plus c. Yes, and that's the same thing. If I multiply that, it becomes x squared plus bx. And of course, you should also know that c is not necessary, because for the same reason, ce to the x becomes the solution for the homogeneous one and will be cancelled out. So we don't need c. So this is the fix. Okay? So none of these terms should be a solution to the homogeneous one. If it is, multiplied by an extra x. That is the recipe. But now, you just see that this will work now, because if I multiply that in, otherwise I have to write the product rule for 3 functions, which is time consuming. So let me just multiply it, and if you have started with that one, it's also okay. Then this will work. Okay? This is not, this, by the way, these are techniques, and if someone has developed these techniques and it's working, then they prove that this method works all the time, so we are using it. Yes? But it was not that very hard, because you could fix it otherwise. Okay, so this means that this will work. Let us check. Now, so this is why I want you to understand at least the source of the problem. The source of the problem is if you guess this one, then one of these terms is the solution to the homogeneous one, which will be cancelled out, because this is supposed to be 0. So apparently, you put 2 degrees of freedom, A and B, but one of them cannot be determined, because it will cancel out every time. Yes? But it was not clear if I multiply it by x it works, but someone has already checked that it will work, and then we are using it. That's the logic. But I want to convince you that it really works here. So what should I do? That is my guess. Yes. So I would take the derivative of that guess. The derivative of the first one, 2ax plus b, multiplied by the second one itself, plus the first one, multiplied by the second one derivative. But the derivative of the second one is again itself. Okay, so I put everything back into the original equation. This expression for y prime minus this expression for y. And then you see the calculations are also extremely simple. And the right hand side is 2x e to the x. And now you see whatever this one is, that is cancelled, and I am not in trouble anymore, because b is not cancelled, and I am lucky it has the correct form as well. Yes, because ex parts are the same. If I can fix this to be this, then I am done. And the fix is simple. 2a should be what? 2, and b, of course, should be in this case 0. Yes? Okay, so what is happening? A is 1. If a is 1, b is 0, then what is y? Y of p, I go back here, a is 1, b is 0. But it is interesting, it becomes a second degree polynomial. So it becomes x squared e to the x. The first guess was it should be a first degree polynomial. It didn't work. But this is yp. Yes? And then the answer will be the general solution, which is c e to the x plus x squared e to the x. This is the solution of this differential equation. You don't need to know these, but it is not hard or very high level, so I just take the opportunity to talk about that. Yes? Yes?
But does this kind of problem only appear when it's an exponential function involved? Because
No, it will be the same. So this is a theorem. I didn't convince you, I didn't go through the theorem. But if you are working only with these three types of functions, polynomials, exponentials, and a mixture of sine and cosine, this method will work. If your guess, by the way, the name I think it's also Swedish name. They say ansats. Yes, is it a Swedish word? I think they call it as a German word, but I saw sometimes in Bedömning, this is also written ansatz. So this is an ansatz that we consider, and then we put it there it works. So yeah, so only for these polynomial, exponential, and sine cosine functions, this will work. Yes, either. So the first guess is to combine the same combination. This is more natural, but I don't start from here because I see that one term will be the solution to the general homogeneous solution. So this will indicate that B will be cancelled out from the calculations. You see, B is not cancelled out here. B was determined to be 0. But here, B is not determined at all. B is completely cancelled off. It is different. Yes? Yeah. If this happens, multiply your ansatz by an extra x. Then it will work. Yes? Okay. This is one optional part. And then let us now, I don't think it is very hard to talk about the general first order linear differential equation. For some reason, the book hasn't talked about that, but we can also talk a little bit about that. Okay, so do you know what I mean? We solve these problems. Y prime plus AY equals, if you don't mind, instead of f of x, let me write q of x. More or less, we know how to deal with this problem. Okay? The general method was what? To multiply both sides by e to the power of ax. The terminology I used for this was the integrating factor. So, this is an integrating factor of this differential equation. Why? Because if I multiply both sides by that, then what happens? The left-hand side becomes the right-hand side of a product rule. The product rule of e to the x y is equal e to the x qx. Yes? And then I told you that e to the axy is a primitive function for that. So this means integral of e to the ax qx dx. Yes? And then I need to find y. I multiply everything by e to the power of minus ax, integral e to the ax qx dx. Yes? And then I told you this is the general solution because in this symbol, you find a primitive function plus a constant c. So the constant c that we need for the general solution is invisible in this symbol. Okay, so this is a very good method. But the problem is that now we want to talk about if this is not a constant, it's another function, because then it becomes the most general case. Okay. My question is that if I want to solve this problem now, if I want to solve this problem, this is the way actually mathematicians think. Now, this is the general form. I don't have a constant, I have a function of x. If it's a mixture of x and y, then it is not linear at all. The topic is the first order linear differential equations. So if I want to keep this linear, then this is the general form. If this is not 1, then I divide everything by that factor, whatever it is, then it becomes 1. So this is the most general case of a first order linear differential equation. But can we solve this problem now in general? Let us say that p of x, I want to go along these lines. But here, finding an integrating factor was not hard. Yes? But can you find an integrating factor in general for these kinds of equations? Because if I can't find that integrating factor, then I am done. But it is not that easy. Okay? So, I mean, the approach to that should also be systematic. It is not easy to guess because we don't know anything about P of x. So, we want to understand this problem. So let us make the problem a little bit hard. For example, instead of P of x to be a constant, let us choose the simplest possible function ever. Let us just put x. And then my question is that, can you find the function qx is whatever you like to? Can you tell me a function so that when I multiply my differential equation by that function, as I did in the previous case, the left-hand side becomes the right-hand side of a product rule? Because if I can't do that, then I am done. At least for the first step. Do you understand what I mean? The reason I repeat this again, because I want to refresh your memory. So here, it was not that hard to guess if I multiply it by e to the power of ax. If I remember correctly, when I asked you, some of you were able to answer that anyway. But if I do that, the left-hand side now becomes the right-hand side. It becomes a product rule. Yes? It was not that hard here because that was a constant. But here, now it's not a constant, it is x. I don't want you to guess. I want you to think systematically. How can I find that function now? Because we don't know. Let us say that you are the mathematician who wants to solve this problem with the same idea of the simple problem. And that is extremely important when you do a research in math problem. You shouldn't start with empty hand, you know. You have some idea which worked for the simple case. First thing is that, is it possible to use the same idea for a harder problem? And if yes, I am lucky. If not, what is the problems? What is the obstacle so that I cannot do that? Let us remove those obstacles. That's a very this is a very good way of thinking when you want to solve a new problem that no one knows about. Yes?
In this case, if we want to find, you have to find a function that when multiplied by x becomes the derivative of that function. So you have, it was some function times y prime and then plus that function prime times y, and then you get.
Okay, how can you answer this question systematically?
Yeah, that's one. Thank you.
Try to understand it from this perspective. Yes? So what you did here, you multiplied by a function. Here you knew the function. Let us say I don't know the function, so I have to give it a name. And the name standard in differential equation is this mu function x. This is very common that in topic of ordinary differential equations, the integrating factor is denoted by mu of x. Mu of x, that's a Greek letter, okay? So my question is that, can I find this function in a way that when I multiply both sides of the equation by that, so let us do that. So this is the scratch work mathematicians do, yes? So you multiplied both sides by mu of x, or mu of x. But your goal is to see that, is it possible that this becomes the right-hand side of a product rule? And by the way, have this logic in mind, because some people want to find all possible mu's. No, you just need to find one mu that will work. That's enough. Yes?
Isn't mu just e to the power, the primitive function of p of x?
No. It's a little bit more complicated than that. This might be, in this case, it is the same, but I don't know. Okay. So what is your guess first? Yes, so you want to see if it is possible. The first guess is to make it as mu of x y prime. I'm just asking, is it possible? Because if it is possible, then I am done. Yes? I don't know if it is possible or not. But if this motivation is taken from here, the simple case. You see, when I multiplied the left-hand side by that expression, coincidentally, it becomes this. If I want to consider this as mu of x, in that case, so that is my first guess. Is it possible to find the function mu of x so that when I multiplied my differential equation by that mu of x, the left-hand side becomes this? Yes?
So for this to be the case, mu of x times x must be the derivative of mu of x, right?
Yes, that's what I'm saying. So this is the scratch work thinking. So you ask yourself, is it possible to find this so that mu of x times y prime becomes equal to mu of x y prime plus x mu of x y? Yes? But then you don't need to think about this hard version. You can simplify it to see how it goes. Let us be positive. Let us say that I can find something like that. Okay, let us see what happens. Then, according to the product rule, this becomes the derivative of the first one multiplied by the second one, plus the first one multiplied by the derivative of the second one. I demand this becomes equal to that, and I want to see if it is possible. Yes? I want you to understand the logic. This is a scratch work, you know. I am asking, is it possible to find mu of x in a way that this holds? Why this is useful? Because if it holds, then I am lucky. I multiplied both by that, then I am done. But this is, then instead of asking this hard question, I simplified my question using the product rule. I am still, don't get lost. I want to find mu of x. So I say that, oh, this one and that one are exactly the same. So cancel them out. Yes? And then what happens here? So mu prime of xy is supposed to be equal to x mu of x y. Yes?
Now we should just move to the other side.
No, you don't need to move to the other side because I told you you don't need to find everything. You just need to find one that works. So it means that y is the same as y here. So your question is that, is it possible to find mu prime so that it becomes this?
Yeah.
Yes?
Doesn't this just become the...
So this is the question. I want you to understand. The question, we started from that simple idea, gave rise to answer this question. So this is the logic behind mathematics research. You know, they don't start from complete scratch. They start from a simple case, try to generalize the idea. Okay, how can I solve that problem now? Yes? Yes? And this is a very important combination we had in Math 4. Do you remember? Yes? What is this one now? Yeah, so it is ln of mu of x totally prime. Is supposed to be x. Yes or no? Okay. But then this means that this whatever inside is a primitive function to the x. So it means what is ln of mu of x? One of them is enough. X squared over 2. Yes? I don't need to put c because I need one integrating factor. But I'm looking for mu of x. What is mu of x? E to the power of that expression, which was not probably easy to guess. We derived that. So, and you see, I want you to understand, because usually people good in mathematics, they want to think about the most general ideas. You don't need to think in that way, because one function that works is enough for your case. So we came up with the idea that for this differential equation, let us now solve it together. So what do you do now? I have, what was the equation? That was my equation. Y prime plus xy equals to what? Q of x. Now you understand that you have to multiply by what? You have to multiply both sides by e to the power of x squared over 2. So let us multiply. So this becomes y prime e to the power of x squared over 2 plus x e to the power of x squared over 2y is equal to e to the power of x squared over 2q of x. Agree with me or not? If my calculation is not wrong, then I don't need to be worried about this mess. This mess is very simple. It is the product of, it's the derivative of a product. Which product? Mu of x, y. Mu of x is derived there times y. Now if I ask you, if you want, you can double check. The derivative of this one multiplied by that one is really this one, plus the derivative of that one. Function repeats itself, but because of the chain rule, you have to multiply by that, which gives you x, that is correct, and then multiply by the second function itself. So everything is in order. And the right hand side is e to the power of x squared over 2q of x. And then the rest of the story you know. Whatever here is, yes, is equal to what? Integral e to the power of x squared over 2q of x dx. And then I'm looking for y, so it becomes e to the power of minus x squared. I multiply everything by the reciprocal, and this is my solution. But I'm just emphasizing that the constant that I am expecting will be invisible in the integral symbol. I'm not saying that calculating the primitive function is easy, but that's a different story. Yes?
So the integrating factor is e to the power of the primitive function of p of x? Or?
No.
No.
That is next question. I want you to do the similar idea for the general case and find the correct formula. What did you say?
E to the power of the primitive function of p of x.
No. I think there should be a minus sign. Yes, that's no, there's no minus sign. You are right.
Okay.
But that's correct, I think. So let us do it in general, okay? If instead of x I have p of x, is the problem becomes more complicated? No. You can hopefully you can feel that, yes. So for example, let me give you this differential equation. Not it's soon now. Let me just give you this idea. So if I want to tackle the general problem, what should I do along the same lines? So what I will do, I will ask myself, is there any function of x so that when I multiply both sides by that function, yes, if I multiply both by that function, the left hand side becomes what? Mu of x times y prime. I'm not claiming that I can't find, but my question, is it possible to find the mu x in a way that when I multiply this, the left hand side becomes that one? But then again, you can immediately answer the question using the same method, yes? Yes, so how should I solve the problem? I say that if there is, this expression should be equal to that expression. So I will start in a scratch paper to see if I can find such a thing, such a function, yes. Do you agree? And then I open it up, derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one is equal to mu of x y prime plus mu of x p of x y. But is it working or not? This one and that one are gone. So mu prime of x, y is mu of x, p of x, y. Then I say that I am just looking for one of them, so y's are in common, so I try to fix this part. So I will try to fix this. Yes, you are right. And then the same idea. Yes? And then what should I do? This becomes ln of mu of x totally prime is supposed to be p of x. So this means that ln of x is what? Is a primitive function for that. So if you don't mind, let me write it as an integral. But of course, in this integral, I need one of them. So I can consider c constant for this integral. And then mu of x becomes what? E to the power of integral of p of x dx. And then the problem is solved once for all. Yes, so it means that you now know how to solve the most general first order linear differential equation. The problem is to calculate integrals. But that's a minor thing, because if you have a formula, you can use numerical methods at the worst case scenario to solve it, and some of them are simple. Yes? So if I want to summarize that, so you already know what to do then. So what you need to do, if someone asks you to solve that, this is completely solved. It doesn't mean practically it is immediately possible, but the idea works all the time. So the first thing that comes to your mind is to do what? Is to calculate mu of x by the formula we derived, and then multiply both sides by that, and then do the rest of the job. At this level, I can give you a question and I wait for you to solve it because it is possible. Yes? So you don't need to use the method of undetermined coefficients at all. It directly gives you the general solution. I want you to understand. So for example, let me give you a mixture of a question from Math 4 and what we learned here. So can you solve this differential equation in full detail? So let me see what you can do. Okay, let me make it a little bit more complicated, okay? Don't start, let me think. Is it working for you or not? Yeah, I think it works. Okay, let us see how many of you can solve that, yes? There is no simple way to guess what is the derivative, what is that function. So, whenever you see that your differential equation is linear of the first order, I hope that you understand that you can solve it in general. Okay, but I intentionally gave you some functions that if you remember everything in Math 4, then you will be able to combine those ideas with what idea we had here to solve the problem. I will also put it in Wolfram Alpha to see how it goes, but don't press the enter, okay? I'll wait for you. Yes? Could you solve it? Okay, so let us do that together. So the first thing you see, you need to understand that this is a linear differential equation of first order, yes? If you compare it with the general form, it is easy to see that this is p of x, and then you need to find what? You need to find mu of x. For finding mu of x, you need to integrate p of x first. So what I will do, so integral p of x dx is integral p of x is tangent of x dx. And this was one of the lessons we had in Math 4, not with this sign. I asked to find primitive function for tangent. But how should I do that? Tangent can be viewed as sine x cosine over cosine x dx. And I told you that this is a famous combination to remember for primitive functions. But there is a minus sign difference here, because if I take this u, the derivative of cosine is negative sine, so but I have sine. So what I do, I put a minus sign here, but I also put a minus sign here to compensate for that. Then if I take this u in my head, this becomes what? U prime. A primitive function of u prime over u is what? Is ln, there is a minus sign here, yes, of what? U, which is So this is this integral. But the the integrating factor, according to the formula we derived together today, is e to that integral. So it is e to the power of minus ln of cosine. I told you that you don't need to consider a constant here because we just need one. But the whole point is that can you calculate this?
It should be x over the 1 over
Cosine. Exactly, because this minus 1 will go up there. So this becomes e to the power of ln of cosine x to the power of minus 1. And this is a very famous formula. Yes? But that minus sign was an obstacle. So I did it like this. I put it up there. But now everything is in order. So it becomes cosine x to the power of minus 1, which is easier to write down. And it was not easy to guess this is an integrating factor. So now I have to multiply both sides of my equation by the integrating factor I found. Yes, I multiply the left-hand side and the right-hand side by that. And then I also multiply the right-hand side by that. Yes, are you with me? Yes?
about the u prime over u. I have that written down as that the answer is ln of the absolute value of u. Is that
No, absolute value is better.
and is better? What should I do with that? Or is
Yes, but then of course I didn't want to talk about these things at this level. Then you have to, because if they want you to ask, they have to give you an interval on which interval you want to solve. Then you can talk about if cosine is positive or negative, and then you can take this absolute value out.
so? Is this just us like we do?
So I'm assuming that cosine is positive. So I'm assuming that I am solving this on an interval on which cosine is positive.
Okay, so we just do it kind of incorrectly, but we don't
Yes, but because as I told you that even this is not correct because this becomes ln of absolute value of u. Yes. But let us say that I want to solve this system on this interval. Yes, but that is completely valid point. Okay, but now if you have done everything right, you don't need to think what this mess is. This mess is clear. What is that mess? Can you tell me what should I write for that mess? You can, of course, you can check. But this becomes what? 1 over cosine x times y prime. You might not believe it, but you can do it and see if it works or not. Yes? Let us check it, by the way. Do you agree that the derivative of this becomes that? Because I am trusting my method, so I'm not considering to check it again. But let us check it. Do you agree that in the Math 4 lesson, if I give you this, do you see that the derivative of that becomes this? Why is that? The first one itself multiplied by the derivative of the second one, good, plus the first one multiplied by, the derivative of the first one multiplied by the second. Yes? If it is Math 4, now I know, I am trusting my calculation, so I know that this should be this one because I solved it in general. But let us double check. If I ask you what is the derivative of 1 over cosine, what is that in Math 4? No, what is the derivative of 1 over cosine? I have to use the quotient rule. So it becomes the derivative of the numerator 0 multiplied by the denominator itself, it is 0, minus the numerator multiplied by the derivative of cosine, which becomes minus sine, divided by the derivative, the denominator squared. But sine x over cosine x squared is exactly that combination, yes? Tangent times 1 over cosine. So everything is in order. But the right-hand side can also be simplified now. It becomes cosine squared x. But then I am looking for this combination. So 1 over cosine x, I don't know how many of you remember how to, because you had the exam, just think back, yes? So you need to calculate the integral of that. Do you remember how to do it in Math 4? the double angle formula. Yes, so it becomes 1 over cosine x y, and then this becomes 1 over 2. I just write the answer, so it's 1 over 2 plus 1 over 2 cosine double angle. Yes, and then it becomes 1 over cosine x y. A primitive function for 1 over 2 is 1 over 2x. A primitive function here is 1 over 2. So it becomes 1 over 4 sine 2x. But don't forget to put the constant c here. This is the formula that I rearrange using the double angle formula for cosine. And I am looking for y, so I multiply everything by cosine x. So it becomes 1 over 2x cosine x plus 1 over 4 sine 2x cosine x plus a constant c cosine x. And I think because I want to put it in Wolfram alpha, I think Wolfram alpha is interested to open this up. So this 2 will be cancelled. It becomes sine x cosine x. So I think Wolfram alpha will answer it in that way, if I am right. But anyway, that is the solution. Okay, let us double check it here. Where is the inter button? So here. So I think I did it right, so let us check. Okay, let me put equality here. Yes, but yes, everything is right. And my prediction was right. I think Wolfram alpha has the tendency to open it up. So that's this. That's the differential equation, which is a very complicated one at this level, but it was not that hard. So my point was not to learn about this differential equation because that's not necessary. I want you to learn that if you want to solve a harder problem, you shouldn't completely ignore the simple problems. Okay, the first thing that comes to mind is that is there any way that I can modify that way of solution to solve a harder problem? Of course, sometimes the answer is yes. You just modify, generalize the ideas. Sometimes the answer is no, then you have to find a completely different route to solve that problem. Yes? But now, let me give you one question from the Indian books, and then let us see if you can solve it. But of course, they have to solve it, I think, in 2 minutes at most. But you don't need to worry about timing. But this is the differential. This is an initial value problem. So I want you to solve this initial value problem. We will not have time to solve it now, but if we have the opportunity, we will solve it later. So the differential equation is, they say that let yx be a solution to the following initial value problem. 1 plus e to the x multiplied by y prime plus y e to the x equals to 1. So it's not complicated that much. And this is the initial value problem. And y of 0 is 2. Which one of these statements is or are true? So that is the Indian way of multiple choice questions. So there might be different solutions. So the questions are, part A, y of minus 4 is 0. So it is not the radio bottom, it's a box bottom, yes? Some of them might be, both of them are true. Y of minus 2 is 0. And then y of x, I will tell you what does it mean. Y of x has a critical point. Critical point means the one that makes the derivative equal to 0. Okay, has a critical point on the interval on this. So a critical point is a point who makes the derivative equal to 0. And y of x has a critical point, no, has no critical point on the same interval, yes? I am saying that this is not a multiple choice question. It might be all of them are correct. It might be two of them are correct. I mean, you have to check all of them.
Can you explain critical point?
Critical point, because there are different conventions, but critical point is a point that makes the derivative equal to 0. Yes? So in principle, you should be able to solve this. Yeah. We will solve it next time. Any questions? Okay, thank you.